Why do less than 1% of Higgs bosons decay in ways we've barely seen? This question sits at the heart of one of the most exciting frontiers in modern physics. The Higgs boson, discovered just over a decade ago, is still revealing its secrets. While most Higgs bosons decay in predictable, well-understood ways, a tiny fraction take a path so rare that even the world's most powerful detectors struggle to catch them in the act. These rare decays are like cosmic whispers, subtle, fleeting, and incredibly hard to spot. But why do they matter so much? And what could they tell us about the universe? How does Atlas even spot these rare events? Imagine trying to find a single unique snowflake in a blizzard of trillions. That's the challenge facing physicists at CERN. The Atlas detector is bombarded with data from billions of proton collisions every second, and only a handful of those might contain the signature of a rare Higgs decay. To sift through this torrent of information, scientists use sophisticated algorithms, machine learning, and a deep understanding of particle physics to filter out the noise and zero in on the most promising signals. Let's dive into the hunt for the universe's sneakiest particles. Each collision inside the Large Hadron Collider is like a mini Big Bang, creating a shower of particles that race through the detector at nearly the speed of light. Most of these particles are well known, but every so often, something extraordinary happens. A Higgs boson is born, and it decays in a way that defies the odds. Detecting these rare events is a bit like being a cosmic detective, piecing together clues from the aftermath of each collision to reconstruct what happened in those first fleeting moments. The Higgs boson is basically physics superstar. It gives other particles mass. Without the Higgs field, the universe as we know it wouldn't exist. Particles would zip around at the speed of light, unable to form atoms, molecules, or anything solid. The discovery of the Higgs boson in 2012 was a triumph, confirming a key piece of the Standard Model. But the story doesn't end there. Understanding exactly how the Higgs interacts with other particles, especially in these rare decays, could open the door to new physics beyond what we currently know. But here's the fun part. Some Higgs decays are so rare, it's like finding a cosmic four-leaf clover. Imagine searching for a single unique event among billions of ordinary ones. These rare decays might only happen once in every 10,000 or even a million Higgs bosons, yet they hold the potential to reveal entirely new aspects of the universe. It's a bit like searching for hidden treasure. The odds are long, but the reward could be a fundamental shift in our understanding of reality. Enter Atlas, a gigantic detector at the Large Hadron Collider. This marvel of engineering is one of the largest and most complex scientific instruments ever built. It's designed to capture the aftermath of proton collisions with incredible precision, recording the paths, energies, and identities of countless particles. Atlas is like a giant digital eye, watching for the telltale signs of rare and exotic processes that could change the way we see the universe. Imagine a 46-meter-long robot camera that sees particles zip by at nearly the speed of light. That's Atlas, smashing protons since 2010. Every second, it records the results of up to 1 billion collisions, generating more data than any one person could ever hope to analyze. That's why teams of scientists from around the world work together, using cutting-edge technology and creative problem-solving to make sense of it all. The scale of the operation is mind-boggling, and the stakes couldn't be higher. So why do scientists care about these ultra-rare Higgs decays? Because they're windows into the unknown. The Standard Model of particle physics is incredibly successful, but it doesn't answer every question. For example, it can't explain dark matter, the imbalance between matter and antimatter, or why gravity is so much weaker than the other forces. By studying rare Higgs decays, physicists hope to find cracks in the Standard Model, clues that could lead to new theories and discoveries. Most Higgs bosons do the usual thing, decaying to bottom quarks. This is the most common decay path, and it's been studied in great detail. But if the Higgs can decay in other, less likely ways, it could point to new particles or forces that we haven't yet discovered. Each decay channel tells a different story about how the Higgs interacts with the rest of the universe. But sometimes they surprise us by turning into pairs of muons, or photons. These rare decays are especially interesting because they're sensitive to new physics. If the rates of these decays differ from what the Standard Model predicts, it could be a sign that something unexpected is happening, maybe even evidence of new particles or forces lurking just out of sight. Catching these rare decays is like stress testing our best physics theories, and maybe finding something totally new. Every time scientists spot a rare decay, they compare it to the predictions of the Standard Model. If everything matches, it's a win for our current understanding. But if there's a discrepancy, it could be the first hint of a deeper, more fundamental layer of reality. That's why the search is so thrilling. Every new result has the potential to rewrite the textbooks. Recently, the Atlas team announced they're closer than ever to seeing these rare decays, sifting through mountains of data to spot the tiniest clues. This achievement is the result of years of hard work, innovation, and collaboration among thousands of scientists, engineers, and technicians. They've developed new analysis techniques, improved the detector's sensitivity, and harnessed the power of supercomputers to process and interpret the data. Each step brings us closer to answering some of the biggest questions in science. It's a big deal, because every rare decay we catch could reveal hidden laws of the universe, or even new particles we haven't imagined yet. The implications go far beyond particle physics. Discovering new physics could help explain the origins of the universe, the nature of dark matter, or the fate of the cosmos itself. It's a reminder that even the smallest, rarest events can have cosmic significance. So, next time you wonder what holds the cosmos together, remember, the universe is full of secrets, and Atlas is hot on their trail. The search for rare Higgs decays is more than just a scientific quest. It's a journey into the unknown, driven by curiosity and the desire to understand our place in the cosmos. With every new discovery, we peel back another layer of the universe's mysteries, getting closer to the ultimate answers. Smash that like, subscribe for more science, and drop your wildest Higgs questions below. Let's geek out together. Whether you're a seasoned physicist or just curious about the universe, your questions and enthusiasm help drive the search forward. Who knows? The next big breakthrough could start with a question from someone just like you. Stay curious and keep exploring.